Hey Internet, my name is Abby and welcome back to Take on Mars. Since the last episode I performed several small lander missions and now only a few missions are left over, and these few missions include the use of the APXS and the probe system. So yeah, we have to do analyze target with APXS and we have to analyze target with probe, and this sounds pretty cool. But well, our current small lander uses still the cycloramic cameras, so I like to modify it once again. In order to install the basic imager cameras, I like to have a basic imager telefocus over here. I like to have a wide angle over here, and I like to have a wide angle down here so that I can see what is going on with my robotic arm. And yeah, now I'm ready. We can now launch the vehicle. I like to make sure that the lander is hopefully landing spot on, and yeah, like this. Now let's launch it. And okay, here we go. We are still protected with our heat shield, but I think soon we should jettison it, and then, yeah, indeed, we have jettisoned now our heat shield, and now we can see a little bit more of the surroundings of the Victoria crater, and when we switch to the outside, we can see that we are pretty far away from the Victoria crater. It's over here, and our landing area is somewhere down here, so yeah, we have well, about 2 kilometers to the center of the Victoria crater. And yeah, so right now we have to perform some analysis out here and to take some pictures, and I hope my lander is able to land more or less spot on. My descent speed is currently about 21 meters per second. Okay, now we are approaching our landing area. Okay, I hope the navigation software is doing a good job and is helping us to land more or less spot on. Okay, now we are drifting a little bit to the side. This is good. This is really good. Okay, easy. Okay, very good. Now we are hovering over our landing area. Oh, there's our parachute. The parachute has just landed, and we have landed as well. Somehow the engine is still running. Okay, explore complete. I like to switch to the interior, and I like to switch to the outside view. Okay, maybe the wide angle view. So what do we have to do? Execute the assigned task. Okay, we have to take a few photos. I think this is more a task for the telefocus. Okay, very good. What else should I take a picture from this rock formation? Okay, very good. And now I need to analyze a specific target. Analyze the specified target. Okay, I think I need to use this camera facing down, and then I should use probe or APXS. Analyze APXS or probe or EAS. I'm not quite sure what instrument should I use. The EAS? Okay, I think I will try at first the EAS. I'm not quite sure if this is the right thing. Unfortunately, there is no specification of the instrument I should use, so I will just try at first the EAS. Maybe we can switch to the outside view. Oh no, down here, send APXS. I should use the APXS system. Okay, now I see what I should use, but okay, let's wait for the EAS system. Maybe we can have still some good results by performing an analysis with this system. We will see. Okay, analyzing, and okay, temporary results, content coming soon. Very good. Okay, now I should use the APXS, so I can now switch back to the robotic arm view, and then I need to select the APXS, and then you can see down here I'm currently controlling the science platform, and when I press, okay, robotic arm right, This is, you can see down here, something is moving. This is a probe, this is a wrong thing, so I need the robotic arm left. And now you can see we are bringing, ooh, don't damage it, we are bringing down the APXS system. Okay, we can start the analysis. You can even see some lightning is going on down there. We can zoom in, hopefully. Can we? Yeah, we can zoom in on this. Very cool, very cool. So yeah, down here is my APXS system, and okay, now we are analyzing it, and now you can see how this thing is working, how this telescope thing is working. I can retract and extend the system. Okay, temporary results coming soon, very good. Okay, now I should do, can I see this somewhere? What kind of system? Oh, the probe. I should now use the probe. So I need now to switch to the right arm. And as you can see, now the probe is extending and is going down into the surface. Oh, I need to switch to the probe. Okay, the probe is ready. Now I'm probing the soil. Very cool, very cool. This is really amazing. This is really amazing to see all these details of the lander and how they are working. This is really amazing. This is so cool. Okay, now I'm analyzing. I can retract now my probe once again. Okay, very cool, very cool. And temporary results coming soon. Okay, now I need to take some more pictures. So I think I will go back to the interior view. What should I... Oh, I need now to switch over to the science platform that I can. Okay, this is more a panoramic view. Maybe like this. Very good. And what should I photograph over there? Maybe with a tele. That's better. A little bit, but no. I think I should use a wide angle. Okay, and... no mission assigned. No mission assigned. Well done. I finished this mission, and this was cool. This was cool. I can now log. I did some exploration. I took 2 photos. I completed 2 analyses, and I took another photo. Okay, very good. I can now disconnect from my small lander, and then I have even mission. I think it was in the... was it in the light crater? I'm not quite sure. Yeah, there's one mission left over. Let me just see the mission details over here. I need to perform the exploration. I need to analyze with a probe. I need to perform an analyze with our APXS and analyze with the EAS, and I have to take several photos. So this is cool. I can now use the last edited vehicle because I think it has still the soil analysis probe, the APXS, the EAS. It has the better cameras. This is cool. So I can now launch this mission, and I have to make sure that I land. Oh, this is a very small landing area. I hope I can land more or less spot on in between these dunes. Okay, this looks good. Let's launch our vehicle. And now it's time to land in the light crater. And we are still protected, or once again protected with a heat shield, as we are performing our descent. Okay, heat shield is ejected. And we are, let me zoom out a little bit. We are landing, I guess, late in the evening. The sun is already quite close to the horizon, and you can see over here the Gale crater is a very, very flat area full of dunes, and well, it's a completely different area compared to the Victoria crater. And now I'm really excited to perform all these different missions. And yeah, we have to land more or less spot on, because over here is a dune, then down here is a dune, and yeah, I hope the lander is performing a good descent and is not running into this dune. But yeah, I think it's doing a great job. It's doing a great job. We are only about 20 meters away from our landing area. Very good. Careful, careful, easy, easy. A little bit more to the side. Come on, come on. And well done, well done. Explore complete. Very good. So what kind of task? I should perform an analysis. I should use blue sand and probe. Okay, I have the probe selected. So now I like now to see this from this point of view. I have the probe selected. I need to use robotic arm, right? Yeah, you can see how the probe is descending down here. Now it's going down into the sand, and now I can probe the soil. This is really cool. Okay, we are probing. And I like this to use all the different camera angles. I can see this from the outside view, or I can even really feel like the scientist or like the engineer controlling the lander and seeing how the probe is being extended and being retracted and so on. Okay, we completed the analysis, very good. Now I can retract my probe. And okay, probe is retracted. Now what do I need to do next? APXS, maybe. At least I know that I have to use the APXS, so I can switch over to the left arm. And no, this is the wrong button. Now you can see how the thing is going down. This is cool, and it's ready. I can start the analysis. Do not move instrument. No, I won't. I will not move my instrument. I will wait for the analysis to be finished. Okay, very cool. And we are analyzing. I can now retract the system and I can switch to maybe the wide angle camera. And here I used the right system. Analyze complete, very good. Now I need to perform the EAS, so I can switch over here to the EAS system and I can start this capturing, very good. Okay, and it's also interesting, we have this information screen over here that we have traveled for 968.5 meters, and this was a distance we have traveled since we have disconnected from our parachute, I guess. And well, this is pretty cool. I'm looking forward to the rover missions when I'm actually driving across the landscape, how much distance I can make with a rover, and I think this is then really interesting. But right now we are just using landers. Okay, analysis complete. Now I have to take several photos. I need to switch over to the science platform, though now I'm able to move this. I think this is another wide angle camera task, like this, capture it. Now I just need to capture this small corner, and now I need to turn around into the opposite direction. I need to photograph this dune, come on, and this dune over here, very good. No mission assigned. Okay, we have completed several analyses. We have the minor task, we have accomplished the major task. Very cool. I can now disconnect once again. Okay, this is really cool. I have now one mission left over, I guess. The North Polar Cap has no missions, the Lyot Crater has no missions left over, Victoria Crater is more or less done, Kaiser Crater has one mission left over, the South Pole has no missions left over, and the Gale Crater is finished. So I think I will do the Kaiser Crater mission off camera because it's exactly the same as I did before. And now I like to start developing a few more technologies. On the one hand, I like to have the robotic arm large lander. So I need the large lander arm housing for flexible robotic extension mountable onto the large lander, allowing installed instrument to reach the area around the lander. This sounds cool. Okay, I can research this one. Then I need the medium power socket system. Improved socketing system capable of powering advanced instruments and vehicle extensions. Okay, 17 hours 15 minutes. And we need the 3-socket turret system. Turret system for a robotic arm capable of housing up to 3 instruments. Okay, then we can install 3 instruments to our robotic arm of the large lander. This is cool. Then I also like to research some of these passive instruments like the environmental monitoring system. Okay, I need then the digital temperature sensor firmware. Firmware for evaluation of atmospheric properties measured by environmental monitoring station. Okay, very good. because I have a lot of money, I hope I have enough money to research all the interesting things. Then I like to have the indirect environmental monitoring, sensors for an indirect record of 6 atmospheric parameters: wind speed and direction, pressure, relative humidity, air temperature, ground temperature, and ultraviolet radiation. Okay, very cool. And the last thing we need is the thermocouple. Bimetallic thermocouple utilizes the principle of voltage generated along the junction of two dissimilar metals when subjected to a temperature gradient. Okay, that's also quite important. Then I also like to have the radiation assessment detector. We need the radiation calorimetry. Electrometric calometers measure the energy of particles. Most particles entering the calometer will deposit its energy into the calometer, where is collected and measured. Okay, very good. Let's research this one. Cesium radioscopy. Cesium radioscopy is used in RAD instrument to characterize the broad spectrum of radiation environment and quantify the flux of biologically hazardous radiation. Okay, research this one. Then we need the solid-state radiation detectors firmware. The firmware evaluates the inducted pulses of current, which are amplified, recorded, and analyzed to determine the energy, number of identity of detected particles. Okay, very good. Research this one. And the last thing we need is the low power socket system. We have this already. What do we need for the dynamic albedo of neutrons? We can't access this one, so we can't research this one. I am thinking about maybe a better camera would be... Yeah, the better camera would be interesting. We just need the color CCD chip. Basic color CCD image sensor utilizes color filter array that passed red, green, or blue light to the selected pixel sensors to achieve color imaging. That sounds cool. Let's research this one. Then of course I need the other one. I'm researching this as well. This is cool. What else do we need? What do we need for the portable electron microscope? I am already researching this one. This is cool. I need 350k. I think I can do this. The recognition software combined the raster scan pattern with the detected signal to produce an image of sample surface, identifying its topography and composition. 39 hours. Wow, this takes a while. Okay, let's research this one. And then I like to have the focused electron beam technology. 400Ks. Raster scanning of samples with focused electron beam. The beam is focused by condenser lenses and passed through scanning coils in the electron column and in the final lens, which deflects the beam in the X and Y axis. Okay, 40 hours. Wow, this takes also quite a long time. And we need the thermoionic electron emission. Thermoionic emission is the heat-induced flow of electrons from a surface of coated metal filament. This occurs because the thermal energy given to the carrier overcomes the binding potential, also known as work function of the metal. Okay, very cool. Let's research this one, and I think this... I'm not quite sure if I need a high power illumination system. Maybe I will research the mast. Okay, I can't access the mast, then I will just research the mast socket system. 700Ks. Yeah, I think I can research this. Turret system for mast capable of housing up to 2 cameras. Maybe this is quite useful. I will research this right now. Okay, I am researching new cameras. What do I need for a high gain antenna? 225. Maybe I will wait with this. I hope it's not so needed right now. Power sources. What do I need for a chemical battery? 50k for the lithium thionyl cell. Cells belong between primary cells using lithium compounds as cathode and thionyl chloride as liquid cathode with lithium, oh dear, serving as the electrolyte. Okay, I will research better batteries and electrochemical energy conversion. Electrochemical energy conversion utilizes the redox reaction between negative electrode and positive electrode connected in series by conductive electrolyte containing anions and cations. Okay, let's research this one, that we have access to better batteries. And I think that's all for now. I think this should then give us access to large lander systems. And yeah, with this, we are at the end of this episode. I will perform the next small lander mission, and then I will bring you back in the next episode with hopefully a large lander mission. And yeah, in this case, thank you so much for watching. Until next time, see you!